Welcome to Is454. I'm Professor Fahmi Jalani. Today we'll be covering cluster analysis for lecture 6. So basically cluster analysis is a technique that used to classify cases into groups that are relatively homogeneous within themselves and heterogeneous between each other on the basis of a defined set of variables. Later we take a look at some example. It could be hierarchical or non-hierarchical procedure. In terms of marketing research in cluster analysis, we have market segmentation, which is clustering of consumer according to their attributes preference. It could be their buying patterns, frequency, spending, understanding behaviors, buyer behaviors. Okay, consumer with similar behavior characteristics are clustered together. For example, we talked about it in our previous class. Identifying with opportunities, new product opportunities. Cluster of similar brands product can help identify competitor or market opportunities. This is good in terms of if you could get data from the rival company, and you can, therefore can analyze and tweak your product to customize to your new customer. Reducing data in terms of preference mapping. Next, we have take a look at steps to conduct cluster analysis. Basically, first step is distance measure. It could be time, it could be a period, it could be a group. Next, you select the clustering algorithm, the pattern, the formula, for example. Determine the number of clusters, how many groups, how many segmentation you require, and then you lastly validate the analysis. Okay, from the data, the output, you analyze whether is it correct or that is the end product that you require. Here, example of one-for-one analysis on the left side and two-for-two analysis of for example a product, and you see the pattern of certain product cluster within themselves. So the procedure I mentioned earlier, we have hierarchy procedure, which is a agglomerative n cluster to get one cluster. Divisive start from one cluster to get n cluster. So this is basically working from ascending, okay, as compared to the previous one, descending. Non-hierarchical procedure, K means clustering, for example. In comparison, hierarchy clustering, basically there's no decision about a number of cluster. Problem when data contains a high level of error, can be very slow. Initial decision are more influential and one step only. Basically, data are being clustered in, for example, a tree diagram, for example. So you see the different level that they have to go through. Non-hierarchical clustering is much faster and more reliable, but you need to specify the number of clusters arbitrarily, okay? And also the need to set up initial seed. Okay, so basically you need to have a plan because you do not want the data to be scattered all over the place with too many categories. Let's take a look at agglomeratory clustering. Here we have a linkage method, for example, linkage single, which is minimum distance, and complete is maximum distance, average linkage. Also, we have the Watts method, compute sum of square distance within cluster, aggregated cluster with minimum increase in the overall sum of squares. Centroid method, the distance between two clusters is defined as the average distance of centroid. Yeah. Next, we have a k-means clustering. Basically, number k of clustering is fixed. An initial set of k seed is provided. First k element and other seeds. Give a certain threshold, all units are assigned to the nearest cluster seed. So new seeds are computed. Then you go back to the step 3 for no reclassification necessary. Having said that, some of the suggested approach, basically you need to perform a hierarchy method, define the number of cluster, then use the k method procedure to actually form the cluster. As for some advantage, and disadvantage, hierarchy has a logical structure, easy to read and interpret. Disadvantage, is unstable and unreliable. Non-hierarchical, more reliable approach. Disadvantage, a series of cluster is usually a mess, okay, and difficult to interpret. Okay, like as we referred to the diagram earlier. Also, not forgetting, both approach could be consecutively. Okay, basically you can act or execute it at the same time. Hierarchical approach could be used to identify the number of cluster. Okay, so one hierarchy could be one cluster. Okay, and outliers could be removed. Remaining object of the non-hierarchy approach is used. Okay, so the input are the numbers of cluster and the cluster centers obtained from the hierarchical approach. Okay. This combine the merits of both approaches. So in this way, user take advantage of both strengths of the approach. It could be hierarchical or non-hierarchical. Okay. Okay, that's pretty much it for cluster analysis. If you have any question, please email me or drop by my office for an appointment. Please stay safe and bye-bye. Thank you.